Three engines feature the ability to calculate mass airflow based on input from sensors on the engine, such as the crankshaft speed position sensor, air intake manifold pressure temperature sensor, turbocharger compressor intake humidity pressure temperature sensor, and the throttle intake pressure sensor. The ISX12N CM2380X120B and L9N CM2380 L124B both feature a 4-wire throttle intake pressure sensor capable of measuring both pressure and temperature. However, the temperature input is not used in the ECM, and the pin for temperature signal is not populated at the time of production. The B6.7N CM2380 B150B will continue to use the same 3-wire throttle intake pressure sensor that was used on the ISLG CM2180, ISX12G CM2180EJ, and ISB 6.7G CM2180 B118 engines. The ISX12N features a turbocharger compressor bypass valve. The valve is a normally closed valve that opens to allow high pressure downstream of the turbocharger and charge air cooler to recirculate back into the intake airstream. The valve is designed to prevent turbocharger chuff. Neither the B6.7N CM2380 B150B nor the L9N CM2380 L124B feature a compressor bypass valve. The following scenes will cover the unique ignition system components found on the engines. All engines feature a newly designed CM2380 electronic control module. The CM2380 ECM is not backwards compatible with the CM2180 ECM. All three engines feature a newly designed ignition control module, ICM, with the same module being used on all three engines. The ICM is both a processor and a capacitive discharge-type ignition coil driver that is capable of performing self-diagnostics that can be communicated to the ECM via the J1939 network. Ignition control modules that were designed for use with CM2180 ECMs are not compatible with CM2380 ECMs. During startup, the ICM performs a self-diagnostic. This self-diagnostic tests for a short in the primary circuit. If a short is detected, the ECM will go into a shutdown mode to protect itself from damage. A key cycle by the operator is necessary to get the ICM out of this mode. The ICM sends a signal to the ECM each time the ICM resets due to a power failure. The ECM interprets the signal as a loss of power to the ICM, or the voltage to the ICM is below minimum threshold. The ECM performs a diagnostic at key on and during engine operation to determine if an ICM with compatible firmware is present on the J1939 network. If signal is lost through or an ICM is detected that is incapable of communicating through the J1939 data link network, a communication timeout error fault code will log. An ICM hardware-firmware mismatch error number FC6882 can also be logged. The ICM's microprocessor must have a minimum of 7 volts to operate correctly. If the proper voltage is not present, the ECM will log a fault code. The voltage fault code can be caused by low supply voltage or malfunctioning ICM. The ICM is capable of monitoring and detecting if the internal temperature is above a predetermined threshold. At the time of production, internal ICM temperature is used for engineering purposes only, and no fault codes will be logged by the ECM. The ICM can detect an open circuit on the primary return connection. If an open circuit is detected by the ICM, a fault code will log in the ECM, depending on the cylinder number that is experiencing the symptom. The ICM monitors the charge voltage after each spark event. If the voltage remains high, the capacitors have failed to discharge. The ECM will log a fault code with the primary coil error and cylinder number that failed. The ICM can also recognize if a coil is disconnected and can monitor the charge voltage output internally for each cylinder. The ICM calculates the average charge voltage across all 6 cylinders and reports the value to the ECM. If the average charge voltage is below a predetermined threshold, a fault code will log. The ICM uses the secondary return line to read information concerning spark plug voltage to help determine ignition coil and spark plug health. As the spark event is taking place, information is sent back to the ICM on the secondary return line pin C. This information is analyzed by the ICM to calculate the breakdown voltage of the spark plug gap. This voltage can be monitored in Insight, but no fault codes will be logged based on this voltage information. The ICM also uses the secondary return line to read information concerning the level of combustion immediately following a spark event. The calculated combustion level is sent back to the ECM. The level is used for engineering purposes only. No fault codes are logged as a result of combustion levels. At startup, the ECM uses input from the camshaft speed position sensor to determine top dead center of cylinder number 1 of the compression stroke. Following synchronization of the camshaft speed position sensor with the crankshaft speed position sensor, the primary inputs for ignition timing during engine operation are the intake manifold pressure temperature sensor and the crankshaft speed position sensor. Using these sensor inputs, the ECM sends timing information and firing commands to the ICM. Using approximately 400 volts, the ICM then sends firing signals to the individual coils. The ICM utilizes extended spark discharge to ensure that adequate spark is delivered to the cylinder under all operating conditions. The individual coil on plug in each cylinder step up the voltage to as high as 40,000 volts. The ICM provides one of the 2 120-ohm terminating resistors found on the engine's wiring harness. Each Cummins natural gas engine has a spark plug that is uniquely designed for the engine. The L9N CM2380 L124B engine uses a spark plug that features a platinum pad and an iridium pad. Due to the orientation of the spark plug in the combustion chamber at a 45-degree angle, the spark plug features side straps to limit the effects that swirling motion of the combustion gases may have on the arc across the spark plug gap. The ISX12N CM2380 X120B engine uses a spark plug that features a platinum pad and an iridium pad. Because of the vertical orientation of the spark plug in the cylinder head, the spark plug does not feature side straps. The B6.7N CM2380 B150B engine features a spark plug with both pads made of iridium. The B6.7N spark plug does not feature side straps. It is important to always refer to QuickServe Online for spark plug gap specifications for the engine you are servicing. Cummins does not recommend re-gapping of spark plugs if they are found to be out of specification. A wire gauge provided by Cummins is recommended for checking if the spark plug gap is within recommended tolerances. Care must be taken to ensure that the wire is passed through the spark plug gap such that it does not damage the iridium or platinum pads. When handling spark plugs, it is important to ensure not to touch the ceramic portions directly with your hands. If contact is made, clean the spark plug ceramic with alcohol and a clean lint-free cloth. The strength of the combustion event is determined by a variety of factors, such as the efficiency of the air, fuel, spark, and exhaust gas recirculated into the system. To determine whether the combustion event occurred as predicted, the ECM uses data for exhaust gas pressure following the combustion event for each cylinder. The ECM compares